Hello and welcome to lecture 7 of the statistical modelling course. In this lecture I'm going to introduce the concept of what's called a generalised linear model, or a GLM. This is not to be confused with GLS, generalised least squares, which we covered in the previous lecture. Generalised least squares is a fairly straightforward extension of the linear model that deals with non-constant variance and correlated dependencies within the variance. A generalized linear model, or a GLM, actually represents quite a significantly different way of modeling data. It uses a different approach and it takes a different outlook. So these are quite a departure from what we've looked at so far. Now these models are still linear in the sense that they have a linear in parameters predictor, but they allow for a non-linear relationship between the mean response and that predictor. And crucially, they're also going to let us model non-normal data. So we're not going to have to worry about normality. We're going to be able to model data from distributions that are not normal. The least squares algorithm is not going to be suitable for the GLM case, so we're going to be using maximum likelihood, and we'll return to the maximum likelihood theory that we introduced earlier in the course. So a significant departure from the linear model, although there is quite a lot of common ground, so many of the concepts that I introduced will be at least partly familiar. Okay, the lecture is split into 7 parts. After the learning outcomes, in parts 2 and 3, I'll introduce the concept of a GLM and describe the structure and components. So these 2 parts are about what a GLM actually is. In parts 4 and 5, we'll cover estimation and inference, which we'll do, as I said, within the likelihood setting. The method used, which is the method used for GLM estimation and inference. And in part 6, we'll estimate GLMs in R. We'll look at a Gaussian, a logistic, and Poisson regressions. And finally, I'll summarize what I've learned. So as usual, we start with the learning outcomes. I'll let you read these in your own time so that you're familiar with what you should know. Really, there is some technical detail in the lecture, and I'm going to go through it at quite a high level. Most of it, I'm going to go through at quite a high level. What I want you to understand is, I want you to understand the principle of GLM, so what it's trying to do, its main components. I want you to understand why maximum likelihood estimation is the way we estimate these models, and I want you to understand how that estimation works, at least in principle. And then I want you to think about these models in terms of their practical applications, and we'll do these examples in R.